The battery system that we picked for the vehicle is a lithium iron phosphate chemistry. The chemistry doesn't go into what's called a thermal runaway when you experience a shorted cell internally. The pack that we're using for the prototype was developed by a company called Lithionics in Florida. They're using 100 amp hour cells grouped into modules that are encased in a fire retardant foam and then put inside a plastic housing with all the battery management system incorporated and all the bus bar systems incorporated in that package. So that package is completely sealed environmentally, and then that will go up in the front of the bus in our battery tray that's also sealed from flooding. The battery system itself has a battery management system that's built in. The battery management system recognizes the voltage and the temperature of each cell that's in the battery box. If any cell during charging starts to approach a preset voltage, usually about 3.6 volts, it will signal to the charging system to turn off, and that protects all of the cells from going into an overvoltage condition. It also protects on the low side, so if any cell goes below 2.5 volts, it signals to the motor controller to reduce the throttle so that the current load isn't as much, and then if it goes below another preset, it'll actually disengage the throttle so that you can't move the vehicle. And that way you protect the battery pack from overcharging, over-discharging, and because of that, we can warranty the battery for a long period of time. We should get over 3,000 charge cycles, which is generally about 5 to 7 years minimum, depending on the conditions.
The nice thing about these battery modules as well is we can parallel them to extend the range if a route needs it. They can easily be replaced by replacing only one module or all of them. It allows it to be much more serviceable. This is our lab battery testing equipment. The top unit is for charging the cells with high power, and the bottom unit is for discharging. This is the same equipment that large auto manufacturers use for their cells. One thing that's nice about these battery modules is the cells are being monitored in real time by the onboard computer system. And this allows us to see potential issues before they affect the vehicle's performance. Lower capacity, lower voltages, so we can have proactive service done on the batteries before they affect the routes and potentially become unsafe. These are the major components to the high voltage power system. The lithium batteries will pass through a power control module that will have voltage and current monitoring, as well as the safety contactors that will pass into the motor controller. The motor controller essentially limits the power from the batteries to the motor, controlling its speed and torque. So this is the onboard battery charger. It has the universal power input, so it takes both 120 and 220 volts AC. It essentially plugs straight into the batteries, and it has communication between the components of the system, allowing it to charge safely.
In the future, we'll look at other suppliers for batteries. We don't really care. We're battery agnostic as far as both the chemistry and the supplier goes. We will also be constantly testing for new technology that comes out so that when better batteries are available, we'll already know about them and understand them and look at putting them into production.